favorite student, good old Anne. A current of 2 amps flows through resistor R1 as shown below. I just have a habit of labeling downhill because as I was doing that, I was looking at stuff. I noticed something else right away. Ella, the voltage from here to here on this branch going through R2, how many volts? They told you. No, read. 8. Say it again. How many volts from here to here? Again, not to make fun of you, but to make a point. How many volts from here to here? Well, how many volts from here to here then? Also, I know 2 things. I did that right away. Oh, and in fact, then I said, I'm nearly done. I can tell you the current. It's going to be V over R. It's going to be 8 divided by 5. Is it 1.6? Is there a 1.6 as an answer, I hope? D, yes, is that correct? Okay. What else could I have asked? I could have given you the same diagram and asked for the power flowing through R2. Because, by the way, how many amps are going through R2? Kyle, how many amps must be going through R2? 0.4. Now I know 2 things. I can find the power. Or I could have asked you to find the magnitude of R2. What is the resistance? What is R2? So same diagram, I can tweak it. Okay? 3 identical light bulbs are placed in the circuit as shown. Which of the following is correct? The voltage and the current are the same for all 3 bulbs. I said that ain't right. Then I wasn't sure, so I labeled downhill. And I made up some numbers. I said, I'm going to pretend this is 48 volts. And I'm going to pretend that this is 5 ohms, 5 ohms, 5 ohms. And I just decided to solve the circuit. That top row, those 2 5s are in series. Nicole, how could I combine those 2 5s? Can we just remember that there's a 10 up there mathematically? I said I'd like to find R parallel. R parallel is going to be 1 over 5 plus 1 over 10, and then take the reciprocal. R parallel is going to be 5 reciprocal plus 10 reciprocal, 3.3 repeating. I said, you know what? This circuit is the same as a single 3.3 ohm resistor with a 48 volt. Oh, you know what? I'm not even sure I needed to do that because in the numbers that I made up, how many volts are flowing through Z? How many volts must be flowing through Z? Yeah, 48 volts has to be. So now I could have gone 48 divided by 5, and I could have said 9.6 amps. How many volts are flowing through the top branch? 48 in total. Is each resistor identical, Ashley, on the top branch? Are X and Y the same? Yes. I saw you zoning out. That's why I'm bringing you back. Are X and Y the same? Yes. Well, you know what? This is going to be 24 volts. This is going to be 24 volts. And I can now tell you the current. It's going to be 24 divided by 5. It's going to be 4.8 amps flowing through here. And 4.8 amps flowing through. Now I can answer the question. The current in Z is less than, no. The current in Z is greater. That's correct. The voltage across Z is no. Now that I solved it, Kenta, mathematically with numbers, could I have solved it just using Kirchhoff's laws and some intuition? I think so. I could have saved myself some time. But when in doubt, there is going to be a using principles of physics right to explain question kind of like this. Then make up numbers if you have to. Number 3, what's the total current leaving the battery? I'm going to start right here because that's where they gave me 2 things. Actually, the first thing I'm going to do is label downhill. Downhill, 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 downhill. All right. I can tell you the current in here. The current is going to be 8.5 divided by 60. 0.141, and then the 6 repeats amps. How else does that help? What else can I do? Ruby, how many volts along this branch? How many volts along this branch? Got to be the same because they're in parallel with each other. 8.5 volts. Knock, knock. I know two things. It's going to be 8.5 divided by 40, 0.2125. And now I can tell you the total current. The total current is going to be 0.2125 and 0.1416 repeating. I brought this on my calculator plus 0.2125 and I get 0.354 repeating, so 0.354 amps. I'm keeping that longer number with the suspicion that I'm going to be using it. Okay. If you got that 3 out of 3, otherwise, here's what I would look for. If I saw that, I would give you 1 mark. If I saw that you had written the 8.5, I would give you 1 mark. If I saw that you had written the 0.2125, sorry, half mark, I would give you a half mark if I saw the 0.2125, and then I would give you 1 mark for combining them using Kirchhoff's laws. Voltage of the battery. Well, okay. I now know that the current flowing through here is 0.354 amps. And I know the current flowing through here is 0.354 amps. I can now tell you the voltage. I know two things. 0.354 amps times 25 is 8.854 volts. And 0.3, you know what, I can do this one in my head. 0.354 I times R, this is going to be 3.54 volts. And now, Kate, I can ski. I can either ski this ski run or I can ski the outer run, but as long as I start at the top of the battery and always go downhill, I can just add up the voltages. So the voltage is going to be 8.85 plus 8.5 plus 3.54, 8.85 plus 8.5 plus 3.54. You're going to get a total voltage of 20.9 volts. Is that correct, folks? People nodding. If you got that, 4 out of 4. Otherwise, I would give you a half mark if I saw that you had written the amperage there, and a half mark for finding that voltage. A half mark if I saw that you had written the amperage there, and a half mark for finding that voltage. 1 mark if I saw that you'd realized I could ski and just add up the voltages, and then 1 mark for the answer. So I didn't need to rewrite that one using my parallel and series. I was able to just solve it. Oh, I know 2 things. This one's going to fall apart too. It says find the power loss. First, I'm going to label downhill. I'm definitely starting here because I know 2 things. So what else do I know here? Current. I can go 6 divided by 4.5, and I get 1.333 amps. I equals 1.3333 amps. Not only that, I know the voltage here. The 9 ohm also is using 6 volts. I know 2 things. It's going to be 6 divided by 9, 0.6 repeating. I equals 0.667 amps. Now I can tell you the total current. I think the total current is going to be 0.666 repeating plus 1.33 repeating. You know what? The total current is exactly 2 amps. 1.9999999 repeating, 2 amps. So I can tell you that's 2 amps, and I can tell you that's 2 amps. And I'm nearly done. It wants the power loss. I know 2 things on the 5 ohm resistor. I've used power equals I squared R because that's what I had. You could have found the voltage using I times R and then used V times I, but I went with 2 squared times 5. Is it 20 watts? Is that correct? If you got that, 4 out of 4. Otherwise, Arian, here's what I would look for. If I saw that, that would get you 1 mark. If I saw that you would realize that you could put 6 volts there and then find the current, that would get you a half and a half. If I saw that you had found total current somewhere, either there or there, I don't care which, and then finding the power. Suppose the 4.5 ohm resistor is removed from the circuit. Okay, so we're basically going to chop off this whole arm. If the 5 ohm resistor is a light bulb, how does the brightness compare? When I talk about brightness, which circuitry concept am I talking about? Voltage, current, power, or resistance? Which one of those is brightness? Okay, you know what? I'm just going to quickly resolve it. Well, hang on. Maybe I can solve it without doing that. We're removing a resistor in parallel. When you remove a resistor in parallel, remove resistor in parallel, our total actually goes up. When you add a resistor in parallel, our total goes down. So if our total goes up, I total goes down. And since I total is what's flowing through here, total squared R, power decreased. The correct answer is dimmer, is it not? I think. Now, many of you would have crunched it. I'll crunch the numbers. So our total, if we remove that, it's all in series. Our total would be 16 plus 9 plus 5. 16 plus 9 plus 5. Your new resistance would be 30 ohms to 30 ohms. And your new current would be 48 divided by 30. Oh, nice try, Mr. Dueck. 48 divided by 30. 1.6 amps, which is smaller than 2 amps. And so your new power would be that number squared times R. Your new power would be 12.8 watts. So if you solved it, if I saw the 12.8 watts, I would give you 2 out of 2 for this paragraph and 1 more mark for circling dimmer. You could either do it numerically or just intuitively with your understanding of circuits. Can you give yourself a clear score out of 16, please? If you need to lawyer with me, now is the time.